Okay, now that you've learned how ice ages happen and how seasons happen, and they obviously have to be related in some ways, and now you say, how can I make my own ice age? As I said to those non-Indians and Indians who don't speak my language, which is called Kannada, like Canada. In many languages in India, grandpa is Aja, Ajoba, and so on. You call it grandpa, gramps, nana, grampy, and so on. And I don't know, Russian would be something, Spanish would be abuelo or something like this, right? So let's come back to making our own ice age. The recipe for an ice age is mainly a question of waiting. Waiting for a long time. The most important factor is that year after year more snow falls than it melts. So how do you make that happen? We are saying something here very important. We are showing ice. We kept calling it ice, but we are showing it only on land, and all the oceans are sitting here looking blue. Why is it that on land you are building ice? Well, because on land, if it snows, it melts in the summer, but if it is winter in the summer, then it doesn't melt, which means more snow falls on top the following year, then the more snow on top. What happens? As snow is water, it begins to build, begins to push down on the snow below, and the snow below is going, oh my god, and then it's freezing up like a ice. It becomes cold and thick and keeps building. If you are old enough, you know there are differences between ice and how this glacier is formed. Glacier. So compressed snow is glacier. It begins to flow if it's on a slope, because typically you build it on a mountain and its top of the mountain gets snow and keeps compressing and then becomes ice like, becomes glacier, and then it begins to flow like honey, like molasses, and then it flows into the ocean. If it is on land, flat land, it will keep building and spreading, and you can see how bright it is and how it can reflect sunlight. You have the Himalayas here and the Andes here and some other rocky mountains or cascades or whatever here. So make sure the continents are positioned well, because if they are in a higher latitudes, they are already cold. If you are down here, you can see there is a lot of glacier here, but there is no glacier in Africa and Middle East, or parts of Australia, India, Asia, and so on and so forth, right? So higher latitudes in both hemispheres have a bit of ice, and there are reasons why there is more ice here in the northern hemisphere than in the southern hemisphere. I think you know why that is, because Antarctica, which is land, has lots of glaciers, but there is ocean here, and the ocean doesn't freeze, which means the air above the ocean is also not frozen, it's warm. So the land continents have to be in the right place, and that they are not all huddled together as they did in the Pangea that we saw before, and as it happened in the age of the dinosaurs. To make an ice age, a good position of land has to be covered with ice, so that you're reflecting more sunlight and keeping less energy and making it colder and colder. This can only happen when there is a lot of land located in cold areas, so around the poles, as is now the case with Antarctica at the southern pole. At the south pole, here it's Arctic Ocean, it's not land, and with Alaska, which extends way into the North Pole region, and you have Canada, Greenland, Scandinavia, and Russia all around the North Pole, which are going into the Arctic Circle. This means that lots of snow falls into the sea, but on land it can stick around from one year to the next and to the next and so on. Make sure that a lot of moisture goes to the poles, because snow is water, it's precipitation. In India you may be getting rain, in parts of Africa you may be getting rain, but when it's cold it's not rain, it's snow. And these snowflakes are shown, the white dots falling here on these places, and the nice snowflake which has a nice structure because of the properties of the water molecule that you probably learned in your class somewhere, right? So make sure that a lot of moisture goes to the poles, which means somewhere it has to be warm enough for the ocean to keep evaporating. Remember, evaporation happens when it's warm, right? So for millions of years there were no ice ages. That was probably because there was a gap between North America and South America. So right now they are connected here, and there is a Panama Canal which has been opened, and there is a Suez Canal which is opened there, and so on. But it is not large enough to change the circulation and the winds and so on and so forth, which gets a bit complicated. All the time when the North America and South America were not connected so closely, the fish could easily swim back and forth between the Pacific Ocean, which sits here, and the Atlantic Ocean, which sits here. The water flowed happily between North America and South America as well, but the two areas of land moved very slowly toward each other until the connection between the two oceans was closed. No more fish could get through. The water could only pass from one ocean to the other. In the far north here that we talked, through the North Sea here into the Arctic, and here into the Bering Sea or Bering Strait, or here far south, because there is a Drake Passage here, and there is a lot of connection here as well from the Pacific into the Indian, and the Indian into the Atlantic Ocean. Even the Drake Passage that's down here at the southern tip of South America, Chile and Antarctica was not always open. So things keep moving, as we said before, right? So the two areas of the land moved very slowly and steadily toward each other until the connection between the two oceans got closed. No more fish could go through. The water could only pass from one ocean to the other in the far north and the far south of the globe. The currents in the ocean changed completely, because if you close a big path, then they have to go this way, and here also you get water this way, and so on and so forth, right? The currents changed completely. That meant that more damp air went to the north, where it created more snow. So the warm water from the tropics, instead of going into the Pacific like this, started to go north into the Greenland Sea here, Labrador Sea, the Iceland Sea, the Norwegian Sea, and so on. Make sure you have mild winters and cool summers in the northern hemisphere, because that's where snow is more likely to stay on lying on the ground once it falls. It will melt away during summer and fall. During a mild winter, more water evaporates than in a cold winter, and this evaporation is needed to make snow. And in the cool summers, much of the snow that remains on the ground remains unmelted. To make the winters milder and summers cooler, you need to use the giant planets Jupiter and Saturn. With their huge gravity that I mentioned before, they constantly pull at the Earth. This has consequences for our orbit around the Sun, as I mentioned. Orbital parameters like the obliquity, the ellipticity, and the precession change. This has consequences for our orbit around the Sun. Sometimes the orbit is almost round, and sometimes it's a bit more elongated. Sometimes the Earth is a little tilted, and sometimes it's a little more tilted. Sometimes in summer the North is closer to the Sun, sometimes it is closer in the south. Every 100,000 years or so, the planets are perfectly positioned to unleash an ice age with the ice albedo feedback. Then the path of the Earth around the Sun is very elongated. The Sun is not as tilted, the Earth is not as tilted, and the distance between the Earth and the Sun is at its greatest during the northern summertime. Then the differences between the seasons are smaller. The winter is not as cold, the summer is not as hot. Summer is milder, winter is milder. During such an ice age, the northern winters are mild enough to make lots of snow and snowfall, and summer times are cold enough to keep the snow from melting. Okay, so there is the Earth, and there's Jupiter, and there is the Saturn, and so on, and the Sun is out there. We said something here that may not be so obvious. Why do we have more snow when the winter is milder? Well, milder air. You remember warm air holds more water vapor, right? I think you have an idea that's the case. Cold air, on the other hand, is very dry. It's bone dry. It makes your skin chap, makes your lips chap. You need to put on the the lip balm, and you have to put moisturizing lotion on your face when it's cold and dry. If it is very dry and there is no water, there is no snow. So it needs to be not as cold. So it's kind of a tricky thing to remember. Cold winter, you think we'll get more snow, but if it gets too cold, then the water is squeezed out and it doesn't snow as much. But a milder winter gets more water vapor and makes more snow. So just get used to this. You got that all many concepts, then you can calmly sit back and wait for a few thousand years. Climate amplifiers will do the rest, like the ice albedo feedback. Sun is doing something, planets are doing something internally, then ice and albedo are doing something together, because the ice is growing and growing and the earth steadily becomes a little whiter. You know what happens then? The rays of the sun are reflected back and the earth cools off even more, which is what we call albedo, and you can see the bright ice here, and the dark land and the dark ocean, they absorb the energy, right? This means that the layers of snow become thicker and thicker. They grow kilometers high to an altitude where it's even colder. Remember, from the surface, when we go to a mountain top or higher in the atmosphere, it's very cold. When you fly in an airplane, they keep it closed and keep you warm. Because it is colder, less water evaporates, because cold air doesn't hold as much water vapor, and there is less water vapor in the air. Water vapor holds on to the heat because it's a greenhouse gas. It takes the thermal energy wanting to go out to space and keeps it. So less water vapor means less heat. The cold makes plants and dead plants matter. Then plant matters freeze. They do not have the chance to start rotting because the microbes don't work so well in the cold. If you put something in the ice, it freezes. You put leftover food or milk and juice and so on in the refrigerator because it's cold, and bacteria do not spoil it. They do not have the chance to start rotting. As a result, their carbon stays trapped in the ice for the time being, and they are unable to release any of that carbon dioxide into the air. The oceans also hold on to more CO2 because it is cold, and the cold Coke can, carbonated sodas, they hold more of the CO2 inside. You keep it cold because otherwise the carbon dioxide will start coming out. So if ocean is cold, it is also keeping more of the carbon dioxide. So the oceans also hold on to more CO2 because it is so cold, and this means less CO2 in the atmosphere. And remember, CO2 is a greenhouse gas which traps the thermal energy. If you remove it, then the more thermal energy is going to space, which means the climate is getting colder. So you have ice albedo feedback reflecting more energy, and you have less and less CO2 in the atmosphere, so more and more cold. As you use, are you tired of your ice age by now? Then put Saturn and Jupiter back where they were. With warmer summers and cooler winters, the ice caps will melt by themselves. More CO2 will be released that was hidden in the plant matter on land and in the ocean, and Earth will begin to warm up again. This says, a long sleep. So nice. Polar bear and other bears are coming out of the hibernation. Imagine they are hibernating over a long ice age. So these positions of the planets and our orbital changes happen naturally because of the gravitational pull of the various planets around the sun, and ice ages happen naturally, but you have internal feedbacks, circles, vicious circles, which build ice and snow. It gets colder, start melting them, it gets warmer, which means melting will happen faster and faster, and ice will build more and more, and it will get colder and colder. So we had these nice cycles of ice ages happening all by themselves. We'll come back and look at volcanic dust and sunspots, a few other things that can block the sunlight and change how much energy we can keep and how much energy is allowed to go to space, which means how warm it gets or how cold it gets. This is almost 15 minutes, but I wanted to tell this whole story in one podcast, and hopefully it's not too long and you haven't fallen asleep. Wake up and listen again. So see you in the next podcast on volcanic dust and sunspots.